Hey there, and welcome to Math 7. This is Unit 3, Lesson 1, entitled How Well Can You Measure? And so we're going to talk today a little bit about how accurately we can measure an object to determine perhaps its perimeter, its area, and things like that. Begin first of all with estimating a percentage here, and it does say that a student got 16 out of 21 questions correct on a quiz, and they want you to use mental estimation to answer these questions. Did the student answer less than or more than 80% of the questions correctly? And the second thing it asks is, did the student answer less than or more than 75% of the questions correctly? So just using some mental math there, take a look at that 16 out of 21 and make a determination about both of those questions there and see what you think you can come up with. Okay, from there in class we went on to looking at a perimeter of a square, part 2 here, and there were 9 squares. Now your teacher in class assigned you or your group 3 of these squares to examine a little bit more closely. I'm going to go ahead right now, just since it's review, and I'm going to look at square A, I'm going to look at D, I'm going to look at H, and I'm going to look at F here for the next part of this activity. Okay? It says on the next page that for each of these squares, we're going to measure the length of the diagonal and the perimeter of the square in centimeters. And so when I did this here, what I'm going to do, if I look at A, for example, and again, mine might be a little different than yours because I have a copy of the book as opposed to your textbook there. When I measure this diagonal length here, I come up with 3 centimeters as my diagonal length for letter A. And I know that my length of my one side right here, if I look at that guy right there, I'm going to go 2.2, something like that for my side length here, 2.2. I did the same thing over here for my diagonal of D, and when I measure my diagonal of D from corner to corner, I measure that out, I came up with 2.3 centimeters there, and my length, side length here was 1.6 when I measured mine. My length of the diagonal for H, again when I just go corner to corner, I measure that out, I came up with about 7 centimeters there. And my length for the actual square was 5 centimeters. And then finally for F, when I went diagonal to diagonal, there to there, I measured that out and had about 6 centimeters. And the length of one side for me was 4.2 centimeters. Again, my numbers might be slightly different than yours because again, mine is just, it's a copy of your book as opposed to your actual book there. Now these numbers here we're going to use to put into a chart on the next page. Okay, so if I look at my next chart, and again with your partner, you had a few of these to do. As a class, you would have had all of them to do. And it says, okay, for your assigned square, measure the diagonal and the perimeter of the square in centimeters. So we did square A, and we said the diagonal was 3. We did square D, at least I did here, and we had 2.3 centimeters. Square F we said was 6, and square H we said was 7. In terms of the perimeter, we had a length of one side, 2.2 here. We had 1.6 for this guy. We had 4.2 there, and we had 5 there. Now perimeter is going to be that side length 4 times because it is a square. So if I just multiply each of these by 4, that's going to give me the perimeter for each one of those squares, A, D, F, and H. And so for A, the square was about 8.8. For D, it was a 6.4 centimeters. Put my units there. Here we had 16.8 centimeters. And here we had 20 centimeters. Okay? And so that's what I had there. It says check your measurements with your group. After you come to an agreement, record your measurements in the table. So as a group, you would have filled in the other ones, and you might have some variance there. That variance is always going to happen because you just might be using your ruler in a little different spot. It's not perfect, it's not accurate, and you're estimating a little bit at some of those lengths measurements. All right, that's okay. Part 2, it says to plot the diagonal and perimeter values from the table on the coordinate plane. Okay, so looking at the diagonal and the perimeter values. We can see that on the vertical side here, we're looking at the perimeter, and on the horizontal side, we're going to be looking at the diagonal. So when we take a look at our first one here, for our diagonal letter A was 3, 8.8. So we're going to go 1, 2, 3, and we'll go up to 5, 6, 7, 8.8 about here. So that's 3, 8.8. That's where A was going to be at. Okay. for me, D was at 2.3, so there's 2.3, and we end up about 6.4. So there's 6.4, somewhere around here. Okay, so there's 2.3, comma 6.4, and that's where B was at. F was at 6, and it went up to 16. So here's 6, 15 is here, so 16 is here, we had 16.8, so maybe about there. Okay, and that's where point F was going to be at. And then point H was at 7 and 20. So we'll go 7 and 20, which is right about here, looks like. Yep, here. Okay, so that's where my 4 points were for the ones that I plotted. Again, with your partners or your classmates, you might find some more of these dots here for B, C, the other letters there. Okay, and so you put that down there. Now, the question is, what do you notice about the points on the graph? And one of the things you might notice, first of all, is that if I was to draw a line from the origin through these, I can get pretty close to getting most of them on a line right there, or at least pretty close to a line, which tells me that there's a relationship between the perimeter and the diagonal there. Okay, so when I look at this, I have a relation between the perimeter and the diagonal, and so when I go back to what I did before, one of the things that's good to look at here is that when we look at this perimeter and diagonal, we called this our y value and this our x value in our chart below. If I was to do a y over x, okay, like our constant proportionality we did before, and do an 8.8 over 3, I end up with a 2.93 there, okay? Over here, this 6.4 over 2.3 comes out to about 2.78. Over here, I have a 2.8, and over here, this one for me was a 2.85. Again, these are all pretty close y over x values here in terms of the relationship between the perimeter and the diagonal, okay? Overall, we'd probably say that our approximate value of k is really about 2.8 when we look at how this works out. So that relationship between the perimeter and the diagonal is our constant proportionality, our k value, which is about 2.8, okay? You're going to need that number when you work on your homework tonight, okay? So I wanted to jot that down for you, that you'll need that when kind of comparing a perimeter and diagonal value for later on, okay? So just keep that in mind and put that in your notes there. In our next activity, we then said, okay, this was looking at how a diagonal and perimeter relate to each other, and we can see that they relate in a proportional manner, and you can get a nice straight line from the origin through there on your points. But let's take a look at those same squares and take a look at the diagonal compared to the area, okay? And so what we had in the table, record the length of the diagonal for each of your assigned squares from the previous activity, and then we're going to calculate the area. Again, I did A, D, F, and H. If you did other ones, that's fantastic. This is what I did. So my diagonal measurements again were 3, 2.3, 6, and 7. Okay. For the area, I took my 2.2, my length of my square, right? Because my square was like this, that was a 3, and I had a side length of 2.2. And I can do 2.2 times 2.2, or I can do 2.2 squared, same idea. And that gave me 4.84. Over here, my length was 1.6, so 1.6 squared is 2.56. The length of F was 4.2, and 4.2 squared is 17.64. And then the length of H was 5, and 5 squared is 25. Okay, so recall that with the perimeter one, we were able to look and see that when I did y over x for my perimeter, I ended up with approximately 2.8 as my k value. Okay, when I look over here, I notice that I have 4.84 over 3, I have 2.56 over 2.3, I have 17.64 over 6, and here I have 25 over 7. Okay, a few things you notice right away. Here, these values are pretty close to each other, aren't they? We're pretty much almost like a 1 value. There's not that much difference. 2.56, 2.3, very similar values. This is pretty close to 1. Whereas over here, if you were to approximate this, this is like almost like 18 over 6, which is pretty much like 3. So if that one's 1 and that one's 3, we can see the relationship is not as firm as what we had with the perimeter and diagonal value before. Okay, so there's our area, and here is our diagonal. Okay, so it says next to examine the class graph of these values. So in class, hopefully with your teacher, you take all your values and you're supposed to put them in one large graph like so. And so you might have had a value like this where you went, well, let's look at our diagonals down below, our diagonal value here, and you went 1, 2, 3, 4, 5, 6, 7, and that's how far out I went. And over here I'm going to just count by 5s just because it's just a little easier because I have some large values there. So I have 5, 10, 15, 20, and 25. 1, 2, 3, 4, 5, 6, 7. And this is going to be my area values here. Okay, so I'm looking at how I plot this out here. 3 is at about 4.84, so close to 5, something like that. 2.3 is at 2.56, so somewhere around there. All right, 6, which is here, is up at 17. So we got to go past 15 up to 17. Let's just say about there. And 7 is up here at 25. Okay, remember our last one, we were able to take our ruler and go from the origin and draw a nice line to show how those will relate together. If I draw a line here, let's just say I'm going to aim for my last one, 25. Okay, we can see that I don't quite have a straight line, do I? In fact, what I really have when I'm looking at area is more of a curved line that grows like this. Okay, later on you're going to see that we call this more of an exponential curve there, or graph, because of the way it's growing up in this direction. It's not going to be linear in a straight line. It's curving that way. So it's curved is what you might have said in class. It's not straight. It's because it's curved, we would also say that it's not going to be proportional. And we knew that was the case when we looked back up here at our values in our table. When we looked at the y over x value, recognize that these are going to be different. 25 over 7, that's a little bit more than 3, isn't it? Because 21 over 7 is 3, 28 over 7 is 4. So this is somewhere in between. This is like 3.5. So we knew that these values all varied quite a bit and don't show a proportional relationship there. So when we look at how the relationship between the diagonal and the area of a square, how is the same as that of the previous activity, how is it different? In terms of its same, we can see that, say that as the diagonal increases, right, so the further we go along the graph this way, we would say that the perimeter and the area also increase. And that's a true statement, right? So as this gets larger, our perimeter and area also tend to get larger. But our big thing is different though, but we could say that the perimeter is proportional to the diagonal. But, whoops, off my page, so sorry. But area is not. Okay, so as the diagonal increases, the perimeter area also increases. So as this gets larger, so does this. But the perimeter is proportional, whereas the area is not. Okay, so that's the big thing, takeaway there from that activity, is that when we're looking at the diagonal with a perimeter, we get a linear type of line that's proportional. We have that 2.8 value there for how that worked. But when we look at the area, we get a curved line because it is not proportional. Okay, for my part here, I'm going to go ahead and skip the "Are you ready for more?" If you did that in class, fantastic. A little interesting experiment here to try to figure out how far the truck goes on Thursday following the route BEFGHA, where they give you all these other little routes and they want you to figure out that part right there. It's an interesting problem, one to think about. So if you want a little challenge to do on your own, go for that there. But in terms of our summary for the lesson, which is where we are now, before we jump into our homework section, we would say that, again, when we measure the values for two related quantities, plotting the measurements in the coordinate plane can help us decide if it makes sense to model them with a proportional relationship. Okay, we're talking about proportional relationship. If the points are close to a line through 0, 0, the origin, then a proportional relationship is a good model. So that means if we can draw a line that is pretty much through the origin like this, and we can get a line that's pretty close, and we're going to say it's a proportional relationship, and a good way to model that is with the graph there. So here is an example that looks like the number of pennies compared to the height of stack in millimeters there. Okay, so again, because it's close to a line, we could say that it appears to be proportional. That makes sense because we're going to have a little bit of variance with the height of the pennies, maybe depending on how worn out they are, how new they are, things like that. In addition, an additional way, to investigate whether or not a relationship is proportional is by making a table. So up top we have a graph, and here's a table. Both are great ways to decide is it proportional or is it not. Here's some data for the weight of different number of pennies in grams along with corresponding number of grams per penny. So 1 penny is 3.1 grams, whereas 2 is 5.6. So in terms of grams per penny, you'd get that by dividing by how many you had. Divide by 1, divide by 2. You end up with a gram per penny. Here we divide this one by 5. Here we divide this one by 10. You can see here that there's a lot of variance. Before, we had numbers that were pretty close together. If you were to look at this, we'd say that these numbers, 3.1 and 2.6, are pretty far apart. I mean, that's half of a gram they're apart in terms of the difference in weight per penny. And that's probably just because of older pennies. It says here that in the metal and pennies changed in 1982 and the older pennies were heavier. So that could explain some of that variance there. But when your y to x value is too different, if there's too much variance in those, you're not going to have a proportional relationship. And so in this case, the table shows us that we do not have a proportional relationship. It's just not close enough. Okay? So let's take a look at your homework. We're going to pause there, and then you can work on your homework, and then you can come back and press play and see how you're doing. All right, so number 1, it says estimate the side length of a square that has a 9 centimeter long diagonal. Okay, a 9 centimeter long diagonal. So here's our square. This is an example, and we had a 9 centimeter long diagonal right there. And it wants to estimate the side length of this one right here. We talked in our lesson part about that relationship, that y over x relationship, that the y over x was going to be equal to 2.8. If you recall that from one of our activities in the lesson itself. Okay, and that was going to be the diagonal value, right? The diagonal value, and this was going to be our perimeter there. Okay, that's our perimeter value. So because the perimeter over diagonal is going to be about 2.8, we can use that then to help us figure out what the perimeter is going to be. Our perimeter is actually going to be then the 2.8 times the diagonal, which in this case here was 9. Sorry for the extra noise today. I came home to do the work and my little kittens are running around. So we have 2.8 times 9 is how I'd get the perimeter there. All right, so 2.8 times 9 is equal to 25.2. That's the perimeter, right? The perimeter is 25.2 centimeters. That's no problem there. But it wants to know what's the side length of a square. And I have 4 of those, so I need to take that perimeter and divide it by 4. And when I do that, I end up with 6.3 centimeters for one side length there. Okay? Again, I had to use that 2.8, that constant proportionality from our lesson in order to solve that one there. Number 2, select all quantities that are proportional to the diagonal length of a square. Really, it's a follow-up on what we did in class. Area. We said that area with a diagonal is going to be a curved line. That is not going to be proportional. Perimeter and diagonal, we've already proven, was going to be somewhat of a straight line there. And the same is true with the side length. You're going to get a straight line as well with a side length because the side length is going to be a constant there. So we would say that B and C are all going to be proportional to the diagonal of a square. Okay, those go together there. Area does not because it has that curved line there. Number 3, great question here, and one that just talks about precision really. It says Diego made a graph of 2 quantities that he measured and said the points all lie on a line except one, which is a little bit above the line. This means that the quantities can't be proportional. Do you agree with Diego? So basically it's like he made a graph like this. he had a line, and on that line he had some points that were on it, and maybe he had one that was a little bit above it. Okay? And so because of that one, he's saying, well, that means it's not proportional. It can't be proportional. Do you agree with him or disagree? Again, you need to write this out. I would probably say, overall, it really depends on a lot of things. It really depends on a lot of things. It could be. It really could be proportional. And the reason for that is it's close, right? And that's the key thing there. It's close. It's really close to the line, which means there could just be an error in just how he measured things. Maybe he didn't measure it accurately. Maybe his ruler slipped a little bit or something like that, or maybe whatever it was. He just had something off in his measurement calculations there. When you get something that's really close, we probably are going to say that it could be proportional. So he could say it's not proportional if he's looking for it to be exact, but in this case here, talking about proportionality, if it's close, we're going to say it's proportional. Okay? So I would probably disagree with him, but you know, depends on what you want to say. Up to you. But you have to explain what you think. Number 4, we have a graph that shows that while it was being filled, the amount of water in gallons in the swimming pool was approximately proportional to the time that has passed. Okay, so we have a graph here. Let's look at the next page, take a look at this graph, and we'll talk about it. So here's our graph of water filling up the pool. And we can see that indeed it does look pretty proportional, right? There's a line that goes through that. It's definitely not a curved line. It looks pretty linear. And so the first question A asks us is how much water after 25 minutes was in this pool. So we take a look at our time. Here's 20 and 30. 25 is about here. And so if I just took my line, I said, well, let's just go up about to where the line's going to be. We'd have a point somewhere about here. Again, we're just estimating here. And so when I look at how many gallons that's going to be, right, and I just draw that straight across, maybe I'm at about 360, 350, somewhere around there. So maybe between 350 to 360 gallons of water. Again, it's just an estimate for about where that could be. Depends on where you drew your line at. Okay? For B, it says, okay, approximately when were there 500 gallons in the pool? Well, 500's here. So again, I go across to 500 and find my point on my imaginary line. And now I'm going to come down to here and say, where is that happening at? Well, somewhere about there. Maybe that's happening between 33 minutes or maybe 35 minutes, somewhere in that range. It's happening there where I'm going to have 500 gallons. Okay? For C, it says to estimate the constant of proportionality for the number of gallons of water, so the gallons of water per minute going into the pool. So we want to estimate the gallons of water, so gallons per minute is what we're looking at here. So one thing you could look at is I'd look for a point that is actually going to line up here. I like how 600 lines up on our axis here, or our grid here, with the 40 right there. Which means I can use that value, 600 over 40, as a good place to start for my y over x. This is my y, this is my x, here's my y, here's my x, 600 over 40. I can eliminate the zeros there and cut this in half to 30 over 2. I can cut that in half again to 15 over 1. And we would say that 15 gallons per minute is my k value for my constant proportionality for the number of gallons per minute that are going into the pool. All right, so hope that helps you out with today's lesson, and good luck, and ask your teacher if you have questions or anything you got. Thanks.